All right, using proportions. Let's go. So cross products. Oh, I got a whole bunch of extra stuff on here. Let's erase everything, which we might have to do again later. Cross products. Given an equation between two fractions or rational expressions, one can cross multiply to simplify the equation and determine the value of the variable. So if I had something like 2 over 3 equals 3 over 4, these would be an example of proportions. Are they equal or not? We don't know yet, but some people used to think of it as cross multiplying, so 2 times 4 and 3 times 3. That's what people usually talk about. This book, I love how they do this kind of circle thing to kind of put them together. Well, what they're simulating, we'll show you in a little bit. So a proportion is a statement of equality of two ratios. So it would just be this kind of statement. Notice that there's no variables in here. So that is a statement of ratio, or a statement of two different. Okay, so here's the key concept portion. So this writes it out in symbols and as an example. Proportion is an equation stating two ratios are equal. So here's what it would look like with just A, B, C, D. And here's what that would look like with two numbers. Notice that you could reduce this one to be 2/3 as well. Okay, so cross products can be used to figure out if two proportions are equal or not. So, so when I take these two here, we cross multiply A to D, so there's AD, and then BC equals BC. And if those two multiplied together are equal, then the proportions are equal. And we'll show you that here in a sec. Okay, so here's what that cross multiplying technically is. So I'm actually multiplying both sides by both denominators. So technically this is a greatest common factor type thing here in order to get both of them to have the same thing. So technically I'm multiplying by B and D on both sides. So I put times this side by BD, both B's will cross out, and this side both D's will cross out, and that leaves me with the top two. That's why cross multiplication works, and that's what we're simulating. We're just skipping that step. So just understand that's what cross multiplying technically does. We're technically skipping a step by using cross multiplication or cross products. Okay, so here's what that looks like in numbers. So if we had two big proportions here, 12 over 84, 12 over 168. If we cross products by multiplying the cross of it, this would end up giving me 12 times 168 and 84 times 12. Once I multiply those out, if they come out equal, like this, check, then these cross products are equal, check. If they don't come out equal, they're not equal. Okay, so here's what that looks like. Determine whether this pair of ratios forms a proportion or not. Remember, if it forms a proportion, they are equal. So first we write those as a proportion. Oh, they even colored it out for you. So then you use cross products in order to do that. They don't do the circle thing here. That's something I added. So we circle those, 2 times 12, 2 times 20, 3 times 12. Multiply those out, 20 and 36. Those are not equal when we simplify it out. Therefore, these are not going to be a proportion. So these are not equal. Yeah, moving on. Okay, same thing. Determine whether the pair of ratios forms a proportion. Now, there's decimals in here. Oh, no! They put decimals in a fraction. It's like two of my worst favorite things in the... Again, breathe. It's not so bad. So first, we're going to try to figure out, are they a proportion? So first, we write them as a proportion. Then we're going to cross multiply, or cross products, whichever you prefer. We multiply them out. It comes out to 6.4 equals 6.4. So yes, these two are a proportion because they are equal. And your turn. Go. All right, so this one we write out. We cross multiply, so I'd have 3 times 10 equals 4 times 9, and yes, you have to write out all these steps to show your work. 30 equals 36. Those are not equal, so no, they do not form a proportion. Or no, 30 is not equal to 36 is probably the best way to say that. These two together, 0.4 times 12 is going to be 0.36. Or sorry, 3.6. And then that's going to be 24. Oh, 4 is going to be 48. So these are going to be 4.8. That's also going to be 4.8 because 2 times 2 is 4, 4 times 2 is 5. Yeah, there we go. So answer, those two are not proportionate. Okay, so they want to actually write that out. So no, they're not a proportion, and 3 over 4 is not equal to 9 over 10. And this side we say, yes, they are equal. Solve this proportion. So here's where we're saying that now we're solving the proportion. Before we were just determining whether they're a proportion. So now we get to solve it. So the difference is now there's a variable in here. So first we set it all up. We cross products, which is going to give me, I simplify those out, 15c, and then I multiply the other two together, comes out to 324. And now we know how to get c by itself, so we divide both sides by 15. And then that gives me my answer of 21.6. So my answer solution is 21.6. All right, solve this proportion. Same thing, we're going to write it out first. We're going to cross multiply or cross products, whichever you prefer. Simplify that out. I'm going to divide both sides by 4.8. And then that's going to come out with 5 equals v. Not too difficult, hopefully. So the solution is 5. Pause this, give it a shot. All right, so I'm just going to go to skip a step here. So I'm going to go 8. I'm going to cross multiply. I'm just going to write it up here. So that gives me 8x equals 3 times 12 is 36. I'm going to divide by 8 on both sides. It's going to give me x equals 4. 16. Yes. And so that gives me 4.5. Wait a second. Yes. Okay. Down here. All right, so I'd cross multiply these. So that'd be 4.2 times 5 and 3 times m. Multiply these together, come out to 21 equals 3m. Divide by 3, divide by 3. 7 equals m. All right, so an architect builds a model of a building before the actual building is built. That's what architects do. The model of the building is 8 inches tall, and the actual building will be 22 feet high. So the model is 20 inches wide. Find the width of the actual building. All right, so first you need to know the actual height. So I'll say, actually, I would underline things. The model is 8 inches tall, and the actual building is 22 feet. The model is 20 inches wide. Find the width of the actual building. So, I highlight the things that are important. So you know the actual height of the building and its corresponding height on the model, because I see here the model is this inch tall and this inch is tall. So I have 8 inches to 22 feet. And we need to know how far it is to correspond with that 20 inches wide. So write and solve the problem using a proportion using ratios to compare the actual height of the building model. We'll let that be W with the actual width of the building. Okay, so the most important thing here is to keep the actual height and the model on the same height, or the same thing. So actual, model, model. If these get swapped by some odd reason, no matter what the problem is you're doing, that's going to be an issue. So you have to make sure you do, both the same size ones. Sometimes we'll do this in geometry with different triangles. So you'll have a big triangle and a little triangle, and this one will be like 2, this will be 5, and they want to know what's this one compared to this one. So you have to make sure you go big over little, big over little. Whatever direction you put them, they just have to be the same. So you can probably ignore this for now. All right, so we'd write that out. We know the actual height was 22, the model height was 8. So the actual width is this, and the model's width is this. From here, we can cross multiply, and we can simplify it. Then divide both sides by 8 will give me a width of 55. So my answer is the actual width of the building is 55 feet. So we could actually check this by putting it in and seeing if they actually worked out, and we can see that they come out to 440 on both accounts. Your turn, go! Okay, so a model of a jet airplane is a length of 9 inches and a wingspan of 6 inches. Find the wingspan of the actual plane if the length is 120. Okay, so the length, find the model airplane. So the 9 inches and 6 inches, and the actual length is 120. So the actual length is 120 over the actual, or the model length is 9 inches. So this would be actual over model. Actual, we don't know, so we need to know that. Actual and model is 6. So we cross multiply these out. That's going to come out to, so I multiply this by this. I'm skipping a small step here. 120 equals 9W. Hope that didn't go too quick there. So 120 times 6 equals 720. And divide by 9, divide by 9. Put that in there. Comes out to 80 equals W. So it looks like the actual find the wingspan would be 80 feet. 80 feet. Circleville Pumpkin Show shows in Cedarville boasts the world's largest pumpkin pie. It weighs 350 pounds and is 5 feet in diameter. Yum. Find the diameter of the pie in centimeters if 1 foot equals 30.48 centimeters. Okay, so I say the pie weighs 350 pounds and is 5 feet in diameter. Find the diameter of the pie in centimeters if 1 foot equals this. So we're going to let x be the pie diameter in centimeters. They've actually given us more information than they needed. We don't actually need the 350 pounds. They're trying to trick you. So the measurement we had before was 1 foot. Our proportion that we need is 1 foot over 38 point something centimeters. Would be 5 feet by how many centimeters? And then we just cross multiply from here. But it's getting this set up that's the hardest part. So the one that is normally done, and then the centimeters, and then feet over centimeters. Cross products, and simplify. Since it was a 1, we didn't have to divide anything. So it would be 152.4 centimeters. And that's all she wrote.